Let's take a look at example 15 right here. Find the equation of the line that passes through the point 2, negative 3 and is perpendicular to the line given by the equation negative 4x plus 2y equals 3. So we're going to solve this in two steps. First of all, we will take the equation of the given line and we will write it in slope-intercept form to determine its slope. We will use this to then find the slope of the line in question, because remember that perpendicular lines, the relationship between the slopes is they are negative reciprocals of each other. And so once we find the slope of the line given by this equation, we will take the negative reciprocal of that one, turn it upside down and change the sign. That in turn will be the slope of the line we're actually trying to find, which we will do here in step 2 using either the slope-intercept formula or the point slope formula, like we looked at in example 14, using one of those two methods. All right, so let's get started on this. Begin by writing this line in slope-intercept form. So to do that, we need to solve it for y. Right? So we're starting with negative 4x plus 2y equals 3. I want to solve this for y. I'll begin by adding 4x to both sides. So I get 2y equals 4x plus 3. And then I need to divide both sides by 2. And what I'll do is I'll just divide every term by 2 here. And that gives me the equation y equals, right here I've got 4 halves, which is 2. So 2x plus 3 halves. Okay. So the slope of my line is 2, right? Because the slope is the number in front of the x right here. So now I want to find the slope of the perpendicular line. For that, I need to take the negative reciprocal of 2. So I'm just going to use this symbol, m with the little perpendicular subscript symbol. So 2 could be, in fraction form, would be 2 over 1. So the reciprocal of 2 over 1 is 1 over 2, or 1 half. The negative reciprocal would be negative 1 half. Okay, so now coming down here, we got to choose one of the two methods to find the equation of the line we actually want. I'm going to choose the point slope formula method. So I will start with the point slope formula. I will replace x1 and y1 with the coordinates of the known point right here. I will replace m with negative 1 half. So if I do that, I get y minus negative 3 equals negative 1 half times x minus 2. And I want to solve this. Okay, y minus negative 3, that's the same thing as y plus 3. So I'll rewrite that as y plus 3. Over on the right, I will distribute the negative 1 half. That gives me negative 1 half x. And then negative 1 half times negative 2 is actually plus 1. And then to solve for y, I will subtract 3 from both sides. So I get y equals negative 1 half x minus 2. Okay. So this is the equation of the line that is perpendicular to the line given by this equation right here. Okay, to wrap up this section, let's talk a little bit about how linear equations can be used for applications. And one common application is using linear equations to represent cost, revenue, and profit. So these can be simple financial applications of linear equations. A typical cost function can be given by this. Notice we're using function notation, c of x, but really it's just a standard linear equation given in slope-intercept form. However, In this case, we're using the equation to represent some, some real world scenario, and specifically a cost, right? So the slope M represents the variable cost per item, and then B is the fixed cost. So there's typically, in a lot of cases, there's some variable cost, right? So, you know, dollars per mile or cents per gallon or something like that, right? And then there is maybe a fixed cost that's just, it's the same regardless of the whatever the other quantity is. Okay? Then we have revenue. A revenue function is of the form P times X, where P is the price per unit, and then X represents the number of units, right? So cost is money going out, revenue is money coming in. And it makes sense, right? If you're selling items at like some price, we multiply the price per unit by the number of units. That the number of units sold specifically, right? That represents the money coming in. And then the profit is the money that you get to keep, your take home, essentially, right? It's the money that you get to keep after you factor in the cost. And you figure out the profit by taking the revenue and subtracting the costs. Okay. Now, the break-even point, this is where when the profit is equal to zero, or specifically when the cost equals the revenue, right? If the costs are greater than the revenue, that means you're losing money, right? Your profit is negative, you're losing money. If your revenue is greater than the cost, that's the ideal scenario. That means you have some take-home money, right? You're coming out ahead. But if the revenue and the costs are the same, that's called the break-even point. Okay, let's look at a couple of examples here. Example 16, at a parking garage, the charge for parking consists of a flat fee of $2 plus $1.50 per hour. Write a linear function to model the cost of parking P of t for t hours. So our function will be P of t. And this is a cost function, right? So it's cost of parking. So it's going to be in the same form as my cost function up here. So we have a variable cost and a fixed cost. The variable cost is the $1.50 per hour, right? It varies based off of the number of hours that you park. So we will represent that in my function as 1.5 times t. It's worth mentioning that we are using, sorry, I'm not sure why that disappeared. We're using the variable t here instead of x because it's representing time, right? So that's why we're doing that. So this is the variable cost, $1.50 per hour. It's $1.50 multiplied by the number of hours parked. But for the total cost, we also need to add in the flat fee, which is the $2 plus 2. Okay. So there is my cost function for this particular scenario. Let's come down here to example 17. At a summer art show, a vendor sells lemonade for $2 per cup. The cost to rent the booth is $120. Furthermore, the vendor knows that the lemons, sugar, and cups collectively cost 50 cents for each cup of lemonade. So part A, write a linear cost, revenue, and profit function that models this situation. Let's begin with the cost function, C of x. Let me try that again. C of x. Okay. So we have to have the variable cost plus the fixed cost. In this case, the variable cost would be the 50 cents per cup, 50 cents for each cup, right? Where x represents the number of cups. So that would be 0.5 times x. And then we add to that the fixed cost. The fixed cost is the cost to rent the booth, which is $120. It's fixed. It's the same regardless of how many cups of lemonade you sell, right? So we add that in. So this function represents our total cost, right? At the end of the day, you sell a certain number of cups of lemonade. You could plug that in for the variable x and solve to get your total cost for that particular day, right? Okay, revenue. Revenue is money coming in. And this is what the money we get from selling the lemonade, right? They sell the lemonade for $2 per cup. So the revenue would be $2 per cup times the number of cups of lemonade. Okay. Then the profit. Let's up a little bit. Okay, let's try this. Profit. Okay. Profit is found by taking the revenue and subtracting the cost, right? And we do that by taking the revenue function, which is 2x, and subtracting the cost function. Oopsies, need a parentheses there. Minus the cost function, which is 0.5x plus 120. Okay. This is equal to 2x. If I write this without the parentheses, it's 2x minus 0.5 minus 120. Okay. And I'm going to write my final revenue function up here. Combine like terms, 2x minus 0. Sorry, I forgot to put x right there. There's an x right there. 2x minus 0.5x. That is 1.5x. Okay. Minus 120. So this function, so these are my key functions, right? The cost function right here. Revenue function right here. And profit function right here. And then coming down here to B, it says determine the break-even point. This says when the break-even point is either when the cost equals the revenue or alternately when the profit is equal to 0. So I could take my profit function and I could set it equal to 0 to find the answer here. So I get this 1.5x minus 120 equals 0. And I want to solve for x, right? So I add 120 to both sides. 1.5x equals 120. This might be a little bit easier to solve without a calculator if we rewrite that decimal as a fraction. 1.5, that's 1 and 1/2, which is the same as 3/2. So I have 3/2 x equals 120. Okay. And now I could multiply both sides by 2 to eliminate that fraction. That would give me 3x equals 240. And then I can divide both sides by 3 to get x equals 80. Okay? So then we can conclude by saying the vendor breaks even when he sells 80 cups of lemonade. When we're doing word problems in this class, there is going to be an expectation that your answer be given as a sentence instead of just a number. Okay, so just a brief sentence, something like this. That will be an expectation on exams and the MP quizzes as well. So, okay, so that wraps up this set of lecture notes. This is your MP6 homework set down here, and we will wrap up this video here. Thank you.